Hello, and welcome to Sleep Gravity. As the sounds around us begin to soften and the rhythm of a long day starts to slow, we will leave behind the familiar motions of Earth and travel to a place very far away, where sunlight has faded to a distant glow and time itself seems to move at a different pace. Beyond the orbit of Neptune, in the cold, dim reaches near the edge of the solar system, Pluto and its largest companion world continue to turn within a balance that has endured for billions of years. If you could stand on a suitable region of Pluto's surface, the first thing to catch your attention might not be the cold, or even the deep darkness overhead, but a large gray sphere suspended in the sky. That is Charon, a companion world so large that it does not resemble a small moon quietly following a much greater body. Against a sky that is almost completely black, Charon's outline appears in the faint light that has traveled billions of kilometers to reach this distant place. The landscape beneath your feet would look unlike anything on Earth. Plains of ice would stretch outward beneath the pale light, broken by mountain ranges, impact craters, and regions of the surface marked by different colors. From that distance, the sun would appear as little more than a point of light brighter than the surrounding stars. Yet it would still be strong enough to cast shadows, illuminate mountain slopes, and draw the horizon as a narrow line between the frozen ground and the space above. Within this scene, Charon would seem to be in no hurry to go anywhere. It would not slowly rise from one side of the horizon, cross the sky over many hours, and sink below the opposite side the way the moon does when viewed from Earth. From a fixed location on Pluto's hemisphere facing Charon, that gray world would remain almost entirely in the same place. The light across its surface could change. The sunlit portion might grow wider and then narrower again. Bright and dark regions could appear differently over time. Even so, Charon would stay near the same direction, as though the sky itself had reserved a permanent place for it. On Earth, we recognize the passing of time through familiar changes. The sun moves from east to west. Tree shadows shift slowly across the ground. The moon appears at different hours, and the stars take turns crossing the sky. These motions feel so natural that we rarely stop to consider that another world might have a sky completely unlike our own. But on Pluto, Charon would not serve as a clock moving overhead. It would be more like a fixed part of the landscape of direction, a sign that could tell an observer which side of the world they were standing on. That presence would not belong to every place on Pluto. If you began a long journey across the surface, leaving the region that always faces Charon and moving gradually toward the opposite hemisphere, the gray sphere would sink lower little by little. At first, it might hang high in the sky. Then it would lean closer to the horizon until half of it was hidden behind the terrain. Eventually, Charon would disappear beyond the ice and distant mountains. But unlike the moon on Earth, it would not return on another night. On the far side of Pluto, Charon never rises. An observer could wait through long hours of daylight, through darkness slowly spreading across the ground, and then through many more cycles of day and night. Yet the sky above would never reveal Pluto's largest companion world. Charon would still exist, still move, and still remain closer than most other objects in the sky. But the entire curve of Pluto would stand between it and the observer. Two people living on opposite hemispheres could therefore exist beneath almost opposite skies. One would always see Charon, while the other would never see it even once. What makes this scene so remarkable is not only the difference between the two halves of Pluto, but also the quiet paradox behind Charon's apparent stillness. Charon is not truly motionless. Pluto is not motionless either. The two worlds continue to orbit one another, rotate on their own axes, and travel together along a vast orbit around the Sunday. Everything in this system is moving, yet the motions have become so perfectly matched that, from Pluto's surface, Charon seems to be held within the same region of the sky. This is not the stillness of something that has stopped moving. It is a stillness created when several different motions find the same rhythm. Charon completes one orbit around Pluto in about 6.5 Earth days. Pluto also rotates in nearly that same amount of time, and Charon turns on its axis at the same pace. This synchronization keeps the same side of Pluto facing the same side of Charon. But the process that created this state did not happen in a single moment, nor was it simply built into the two worlds from the beginning. Behind it lies a very long history of gravity, changing rotation rates, and motions so gradual that no human lifetime could ever witness the entire process from beginning to end. Pluto is larger than Charon, but the difference between them is not as great as it is between most planets and their moons in the solar system. Charon's diameter is about half that of Pluto, large enough for its gravity not only to keep itself in orbit, but also to make Pluto respond with a motion of its own. The true picture of this system, then, is not one world sitting perfectly still at the center, while a small moon circles around it. Both are moving under each other's influence, though the deeper details of that shared dance still lie ahead in our journey. For now, there is no need to leave this frozen surface. We can simply keep our gaze on Charon a little longer, while the sunlight slowly shifts and the shadows lengthen so gradually that the change would be almost impossible to notice with the naked eye. The gray sphere remains there, not entirely motionless, yet never crossing the sky. A quiet reminder that stillness can sometimes be created by motions of extraordinary precision. Today, we know that Charon is a world with mountains, plains, craters, and a history of its own. But for most of the time humans observed Pluto, no one knew it existed. In old astronomical photographs, Pluto appeared only as a tiny faint point of light, far too distant to reveal any structure. Charon remained hidden within the glow of the world it accompanied, even though the two had been turning together long before human eyes first looked up at the sky. Then, on a day in 1978, a very small detail in an image of Pluto caused an astronomer to pause longer than usual. It was not a clearly defined sphere, nor was it a discovery that seemed astonishing at first glance. It was only a slight bulge of light extending beyond where Pluto's shape should have appeared perfectly round. From that almost invisible clue, the story of two worlds forever facing one another truly began. The slight bulge of light extending from Pluto's image did not have the clear appearance of a newly discovered world. It had no rounded outline and revealed no mountains, impact craters, or other features that might have allowed an observer to immediately recognize a celestial body hidden there. In the black and white astronomical photograph, Pluto was still only a tiny point of light, while the irregular shape beside it looked like a faint smudge that could easily have been dismissed as an equipment error, a star lying by chance in the background, or a minor flaw on the photographic plate. In June 1978, at the United States Naval Observatory Station in Flagstaff, Arizona, astronomer James Christie was carrying out work that had nothing to do with searching for moons. He was reviewing photographs of Pluto to measure its position more accurately, helping scientists improve their calculations of the distant world's orbit around the Sunday. It was work that required more patience than adventure, examining one image after another, comparing points of light, measuring extremely small distances, and determining the position of an object billions of kilometers from Earth. At the time, astronomical images were not recorded with modern digital sensors. Light collected through a telescope was often captured on glass plates coated with light-sensitive material. After a sufficiently long exposure, stars appeared as tiny points across the plate, while Pluto, being so distant and so small, also showed up as little more than a dim speck among countless other sources of light. Although Pluto itself was a world thousands of kilometers across, the immense distance compressed its entire surface into a single faint mark, too unresolved for the human eye to see its true shape. That was why the small bulge beside Pluto drew attention, not because it was beautiful or striking, but because it did not quite match what should have been there. If the image had been blurred by movement during the exposure, the nearby stars should also have been stretched in the same direction. If there had been a flaw in the glass plate, the mark might have remained fixed in the same place on the photographic surface. Yet the surrounding stars were still round, while Pluto alone seemed to be extended toward one side. A single photograph could not reveal very much. In astronomy, subtle clues often have to pass through a careful process of elimination before they can be treated as evidence. Light can be affected by Earth's atmosphere, by the way a telescope is adjusted, by the development of the photograph, or by a background star lying directly behind the object being observed. So instead of rushing toward a conclusion, Christie returned to the archives and began searching through images of Pluto taken in earlier years. There, among photographs originally stored for entirely different purposes, the same unusual feature appeared again. Sometimes the bulge lay on one side of Pluto. At another time, it shifted in a different direction. In some images, it disappeared altogether, leaving the point of light nearly round once more. What mattered was not any single photograph, but the way all of them began to form an orderly pattern when arranged through time. The bulge was not appearing at random. Its direction changed according to a repeating cycle that lasted a little more than 6 days. If the cause was an object orbiting Pluto, there would be times when it appeared off to one side, stretching the combined image. At other times, when it passed in front of or behind Pluto from Earth's point of view, the light from both bodies would nearly overlap, making the image appear rounder again. A world that could not yet be seen separately was revealing its presence through the rhythm of its motion around the larger one. Christie's colleague, astronomer Robert Harrington, used orbital calculations to test that possibility. If the protruding light truly belonged to a moon, it would have to appear in predictable positions during future observations. This was an essential step, because a scientific explanation must do more than fit what has already happened. It must also tell us what should appear next if the explanation is correct. In early July 1978, the telescope was pointed toward Pluto again. In the new images, the elongated shape appeared close to where the calculations had predicted. A feature that could once have been dismissed as a flaw in the photograph had now become the trace of an object moving in orbit. A few days later, the discovery was announced to the astronomical community. Pluto had not been traveling alone, as humanity had believed for nearly half a century since its discovery. The new world was first given a temporary designation, as many newly discovered celestial bodies are. Christie proposed the name Charon after the ferryman of ancient mythology, a figure associated with Pluto's underworld. The name also carried a more personal meaning because its opening sounds echoed the name of his wife, Charlene. In a single short word, the mythology of a distant world and a small piece of human life happened to meet. Even then, Charon did not yet appear as the gray sphere that a spacecraft would photograph decades later. In the images from 1978, it had no separate visible surface and remained blended into Pluto's light. Humanity knew it existed not because its shape had been clearly seen, but because a repeating pattern had been recognized within a series of very small traces. The discovery came from watching long enough to distinguish coincidence from orderly motion. Those old photographs also remind us that data can preserve more than its original observers intended to find. An image taken to measure Pluto's orbit also contained evidence of another world. The faint bulges had rested quietly in the archives until someone placed them side by side in the proper order of time, allowing the hidden story within them to begin emerging. From that moment on, Pluto was no longer simply a solitary point of light beyond Neptune. Beside it was another object with its own period, its own orbit, and enough brightness to alter the appearance of the entire system. But as astronomers continued making measurements, the surprise was no longer limited to the fact that Pluto had a moon. The newly discovered world seemed far larger than a faint companion that could easily be pushed to the edge of the story. In the years that followed, the light of Pluto and Charon would be separated through increasingly precise observations. Each careful measurement clarified the proportions between them, and with that, the familiar picture of a large world orbited by a small moon began to seem less appropriate. Charon had remained hidden within Pluto's light for a very long time, but once it was recognized, it could not easily return to the role of a minor detail. From the moment the slight bulge of light beside Pluto was confirmed to be a world in motion, The old photographs could no longer be viewed in quite the same way. Charon had emerged from the blur of the data, but its mere existence was not the only reason astronomers continued to pay attention. As the measurements gradually became more precise, another feature began to stand out. The newly discovered world was far larger than the familiar image of a small moon beside a planet might suggest. Charon is about 1,200 kilometers in diameter, nearly half the diameter of Pluto. That proportion becomes easier to grasp when the two worlds are placed side by side within the same frame. Pluto is still larger, its surface patterned with alternating regions of light and darkness and subtle shades of color that later observations would eventually reveal. Beside it, Charon appears more subdued, almost silver gray, yet it looks nothing like a tiny point quietly following along. The two spheres hang in space as a pair of bodies close enough in size for the eye to immediately recognize that this relationship is not quite like most other planet and moon systems. Even Earth's moon, which is considered quite large in comparison with our planet, has a diameter only about 1/4 that of Earth. Charon, by contrast, is nearly half the size of Pluto. This does not mean the two systems formed in the same way, but it does help explain why this distant world quickly became such an unusual case. With proportions like these, Charon's gravity cannot be treated as a minor influence at the edge of the story. It is strong enough to play a clearly visible role in the shared motion of the entire system. For many years after its discovery, Charon existed in human understanding only as numbers and points of light. Improving telescopes could separate its light from Pluto more clearly, allowing astronomers to measure its orbit, size, and brightness. But the enormous distance still kept its true surface beyond view. Scientists knew that Charon was a large world, but they did not yet know what that world looked like. Only when the New Horizons spacecraft passed through the Pluto system in 2015 did Charon finally appear as a landscape with a form and history of its own. The images sent back revealed a sphere that was neither smooth nor featureless. Light brought out regions of higher and lower terrain, ancient impact craters, and long fractures stretching across the icy crust. It's then Medial 7. Although the deeper geological story of Charon still lies ahead in our journey, simply seeing that surface was enough to change the way people felt about it. This was no longer a moon known only through its motion around Pluto, but a world carrying its own traces of history, preserved for billions of years. That moment also reminds us that the word moon can sometimes make a celestial body seem smaller in our imagination than it truly is. We often think of a satellite as something standing at the edge of the scene, receiving light from a larger planet and gaining meaning only through its orbit. But Charon does not need Pluto in order to be a landscape. Its surface still has highlands and lowlands, places shaped by impacts, and regions that may once have changed because of heat from within. It orbits Pluto, but its history is not completely dissolved into Pluto's own. Seen more broadly, Pluto does not have only one companion. 4 other small moons also move around the system, but they are far smaller than Charon and have irregular shapes. If the entire family were placed within a single image, Charon would stand out immediately. The 4 smaller moons would resemble distant fragments scattered near the edges, while Pluto and Charon would form the clearest central pair. That contrast is why the relationship between the two larger worlds became so important when scientists began trying to understand how the entire system formed and evolved. Because of their unusual size ratio, Pluto and Charon are sometimes described as a binary system. This is not an official classification used by every scientist, and Charon is still regarded as Pluto's largest moon. Yet the image of a binary system captures something important. These two worlds do not create the familiar scene of an almost motionless center with a much smaller object circling around it. Pluto is still larger, but it does not remain completely still beneath Charon's gravitational pull. We can picture the two spheres suspended in darkness, separated by nearly 20,000 kilometers from center to center. Pluto is brighter and more colorful, while Charon is grayer and more subdued. The distance between them is wide enough for each to remain a distinct world, yet close enough for either one to appear enormous in the sky of the other. As Charon moves around Pluto, Pluto also makes a smaller motion in response. They are not equal, but both take part in the same shared rhythm. This is where the usual picture begins to feel incomplete. When we say that a moon orbits a planet, we often imagine the planet sitting still in the middle like a fixed post, while the moon traces a circle around it. That picture is accurate enough in many cases because the central body is so much larger that its own motion is difficult to notice. With Pluto and Charon, however, the difference in mass is not great enough for Pluto's motion to be ignored completely. If the entire system were observed from far away over the course of one cycle, Charon would travel along a broad path, while Pluto would also move along a smaller one. Both would circle, like two objects joined by an invisible cord, neither able to pull on the other without responding in turn. Gravity does not act in only one direction. It requires each world to change its position because of the presence of the other. But if both Pluto and Charon are moving, where is the true center of their motion? The answer does not lie on Pluto's surface, nor does it lie inside Charon. Between the two icy spheres is an invisible point of balance, with no landscape, no color, and no complete belonging to either world. It is around this point that both bodies move in silence, with such steady precision that, from Pluto's surface, Charon still appears to remain fixed in the sky. And sometimes, the center of a system does not lie within its largest body, but in the empty space between two worlds. The empty space mentioned at the end of the previous story was not simply a poetic way of making the motion of Pluto and Charon seem more mysterious. It is a real location in physics, even though there is no ground there to stand on, no marker floating in space, and no light of its own for the human eye to see. Astronomers call this position the barycenter, meaning the balance point of all the mass within a system. Every pair of celestial bodies bound together by gravity has such a point. When a large object and a small object move together, both are actually orbiting their shared barycenter, though that point usually lies deep inside the larger body. From a distance, this creates the impression that the larger world remains completely still at the center, while the smaller object simply circles around it. That picture is convenient, and in many cases it is close enough to reality, but it conceals part of the motion that is always taking place. Earth and the Moon offer a familiar example. The Moon orbits our planet, but Earth also responds to the Moon's pull with a small motion of its own. The shared barycenter of the pair still lies beneath Earth's surface because our planet is far more massive than the Moon. Viewed from a great enough distance, Earth would not travel along a perfectly smooth path, but would shift slightly around a balance point located within its own body. That motion is real. It is simply not large enough to change the familiar image of the Moon circling Earth. With Pluto and Charon, the unusual proportions between the two bodies make this relationship much easier to see. Pluto is still more massive, but Charon is not so light that its influence can remain completely hidden inside the larger world. Charon has about 1/12 the mass of Pluto, enough to pull the balance point beyond Pluto's surface and place it in the open space between the two spheres. That point lies closer to Pluto because Pluto is the heavier body, but it is not located inside either world. We might imagine an invisible bar connecting the center of Pluto to the center of Charon. If the two spheres were placed on an enormous scale, the support would have to sit closer to Pluto to keep the entire system from tipping toward either side. There is no such scale in space, but the same principle of balance still applies. The position where the mass of both worlds is balanced is the point around which they move together. Charon, then, does not circle a completely motionless Pluto. It traces a broad orbit around their shared point, while Pluto follows a smaller path on the opposite side. When Charon is on one side, Pluto's center shifts slightly to the other side of the barycenter. Half a cycle later, their relative positions have changed, yet the balance point remains between them. This arrangement repeats roughly every 6.5 Earth days, as steadily as a mechanism that has been running for so long that all its separate motions seem to have blended into a single rhythm. If a camera were fixed to Pluto itself, we would see Charon moving around it and might easily believe that Pluto was an unmoving center. But if the frame were held steady on the shared barycenter, the scene would look very different. Charon would travel along the wider path, while Pluto would also sway around the same point. Neither world would remain still. The larger body would simply move less because most of the system's mass is concentrated within it. Long before New Horizons approached the system, this motion was already known through orbital measurements. Astronomers tracked the positions of Pluto and Charon across many photographs, determined how long Charon took to complete one orbit, measured the distance between them, and combined those observations with the laws of gravity. From the way the two sources of light changed position over time, scientists could infer the mass of the entire system and the location of its balance point, even though no one could see the barycenter directly in the way one might see a mountain or an impact crater. As New Horizons drew near the Pluto system in 2015, a concept that had previously existed only in calculations began to feel more visible. Sequences of images taken at different times showed Charon changing position around Pluto, while Pluto itself also shifted in a steady pattern. In an animation that kept Pluto fixed in the frame, the larger world's gentle wobble would disappear. But when the frame was centered on the shared barycenter, the motion of both worlds became clear. One bright sphere and one gray sphere, circling an imaginary point in the darkness. What makes the barycenter especially interesting is that it is not a third object controlling the two worlds. No separate force radiates from that position, and no invisible particle of matter is pulling Pluto and Charon around it. It is simply the mathematical result of how their mass is distributed, much like the balance point of a ruler can be identified even when nothing has been attached there. The gravitational pull between Pluto and Charon is what creates the motion. The barycenter merely allows us to describe that motion more accurately and more clearly. A balance point like this is not absolutely fixed within the universe. While Pluto and Charon circle around it, the entire system continues along its long orbit around the Sun. The Sun itself moves through the Milky Way, and the galaxy continues drifting within even larger structures. The shared barycenter travels with the pair, like the center of a spinning motion, being carried along on a much greater journey. The two worlds are not circling a point that stands still in space. They are circling a point that always travels with them. Seen this way, the Pluto-Charon system looks very different from one built around a rigid center. Its center is not a sphere and not a place that could ever be photographed up close. It is an empty point defined by the presence of both worlds. If Charon were far less massive, that point would sink back inside Pluto. If Charon were heavier, it would shift farther toward the space between them. The present location of the barycenter is therefore a quiet sign of just how important Charon is to the shared motion of the system. Yet orbiting the same point does not fully explain the scene that opened our journey. Two objects can circle a barycenter while continually turning different faces toward one another. Earth and the Moon also have a shared barycenter. But from the Moon, Earth does not remain fixed in quite the same way that Charon does in Pluto's sky. There is another layer of motion we still need to understand: the rate at which each body rotates around its own axis. Somewhere in the distant past, Pluto may have rotated more quickly, while Charon may have traveled along a different orbit. The gravity between them did more than pull the two spheres around their balance point. It also acted upon the shape, interior, and rotation of each world. Over immense spans of time, those small effects accumulated, gradually altering their motions until Pluto's day, Charon's day, and their shared orbital period all settled into the same rhythm. The invisible point between the two worlds tells us where they orbit. But to understand why they always keep the same faces turned toward one another, we must listen for an even slower influence: the way gravity quietly reduces the rotation of an entire world. The invisible point between Pluto and Charon tells us where the two worlds are orbiting, but it still does not explain why they always keep nearly the same faces turned toward one another. To understand that, we need to look at an effect far slower than a single orbit, one that cannot be noticed over a few days or even a few years, yet can alter the rotation of an entire world if repeated for long enough. We often imagine gravity as an invisible cord pulling two objects toward each other. That picture is not wrong, but a planet or moon is not a tiny point with no size. The side of its surface closer to the companion body feels a slightly stronger pull than the side farther away. This very small difference acts across the entire body, stretching it gently in the direction of the object, creating the gravitational force. On Earth, the oceans are where this effect is easiest to see. Sea levels rise and fall with the motions of the moon and the sun, creating the tides. But tidal forces do not act only on water. The rock beneath our feet also changes shape by a small amount, though not enough for the naked eye to notice. On cold worlds like Pluto and Charon, the ice and the rocky material within may also flex slightly under the pull of the other world. If celestial bodies were perfectly rigid and changed shape instantly in response to gravity, the story might end there. But ice and rock need time to respond. They do not deform immediately and return to their original shape without any loss. Inside a world, material must shift, compress, stretch, and rub against itself. As a result, the slight tidal bulge does not usually lie exactly along the line connecting the two bodies. Instead, it is displaced slightly from the direction of the gravitational pull. That small displacement is what can change a world's rotation. We can imagine a spinning top turning quickly on a table. Without resistance, it might continue spinning for a very long time. In reality, friction quietly removes some of its energy, causing the rotation to slow. Pluto and Charon have no tabletop beneath them and no thick atmosphere creating drag, but the deformation taking place inside each world plays a similar role. Gravity continually pulls on the material that has shifted out of alignment, changing the rate of rotation very slowly over time. Each time ice and rock are stretched and then adjust again, a tiny amount of the energy of motion is converted into heat. Over a single day, that heat would be almost insignificant. Across millions or billions of years, however, the total effect can become substantial. A world that once spun quickly may slow down, its days gradually growing longer, while the icy crust may preserve traces of that prolonged deformation. In the distant past, Pluto and Charon almost certainly did not begin with the rhythms they have today. Pluto may once have rotated faster, while Charon may have had a different spin rate and orbited at a different distance. The exact details depend on models of how the system formed, but tidal forces will always tend to reduce the difference between the rate of rotation and the rate of orbital motion. Charon is smaller than Pluto, so the gravity of the larger world acts strongly across its entire body. Over time, Charon's rotation gradually slowed until it took exactly as long to turn once on its axis as it took to complete one orbit around Pluto. Once those two periods became equal, the same side of Charon always remained facing the larger world. Earth's moon is in a similar state. It never stops rotating, even though from the ground it often seems to keep the same face turned toward us. During the time the moon takes to complete one orbit around Earth, it also rotates exactly once on its axis. Without that rotation, different regions of the moon would take turns facing our planet. But the Pluto-Charon system has gone one step further. Charon was not the only world slowed by tidal forces. Pluto itself also felt a powerful tidal pull from its unusually large companion. In most planet and moon systems, the central body is so massive that the slowing effect upon it is much weaker and may never bring it into full synchronization. In Pluto's case, Charon's pull was strong enough to gradually change the length of the larger world's day as well. Eventually, three motions settled into the same rhythm. Charon completes one orbit around Pluto in about 6.4 Earth days. Pluto rotates once in nearly that same amount of time, and Charon also turns on its axis over a similar period. Scientists call this mutual tidal locking, or double synchronous rotation. The word locking may suggest that the two worlds have been held rigidly in place, but the reality is exactly the opposite. Pluto and Charon remain in constant motion. Charon continues to travel around the balance point between them. Pluto follows its smaller path, and both worlds continue rotating on their axes. What makes the system unusual is simply that these motions have become synchronized. Each time Charon completes one orbit, both worlds have also completed one full rotation, allowing the same hemispheres to continue facing each other. The spinning top in our earlier image does not come to a complete stop. It simply slows until its rotation matches the motion governing the system around it. For Pluto and Charon, this process did not unfold over a few minutes, but across spans of time so immense that they are difficult for the human mind to grasp. Science can describe the general mechanism quite clearly, but it cannot reconstruct every step of the distant past with complete certainty. How quickly Pluto once rotated, how close Charon may have been in the beginning, and how efficiently the interiors of both worlds dissipated energy are still questions explored through models. What can be seen with confidence is the final state. The two worlds have settled into a shared rotational rhythm. Charon's stillness in Pluto's sky is therefore not an accident. Behind it lie countless tiny deformations of ice and rock, energy slowly transformed into heat, and rotations that weakened little by little over time. There was no single moment when the entire system suddenly changed. There was only a process so patient that, within a human lifetime, everything would have seemed exactly the same as before. Yet, once that process was complete, the result could be seen without any measuring instrument at all. Across one half of Pluto, Charon is always present in nearly the same region of the sky. Across the other half, it never appears. The light continues to change. Darkness continues to move across the icy plains, and the gray world overhead remains almost fixed in place. Gravity did not make the motion disappear. It simply brought several different motions into the same rhythm, leaving its clearest trace in the sky above Pluto. Once those rotations had slowed and settled into the same rhythm, the result of that process drawn out over billions of years was no longer just something that could be described through orbits or numbers. On Pluto's surface, it became part of the scenery itself, present in the very arrangement of the sky. Across the broad region that always faces Charon, that gray world remains almost fixed in place. It does not rise from one horizon, drift slowly overhead, and sink on the other side the way Earth's moon does. It stays there, steady and quiet, while the light around it continues to change. If we stood in the region facing almost directly toward Charon, we would see it high in the sky. The distance between the two worlds is not especially large on a planetary scale, so Charon appears far larger than the moon does when seen from Earth. Though it is not brilliantly bright, it is still large enough to become the most striking feature against the nearly black sky. Charon's cold gray surface reflects the weak sunlight, revealing a round disk with a quiet presence, sometimes more fully lit, sometimes reduced to only a thin illuminated portion. What makes the scene especially unusual is that Charon can change phase without noticeably changing its place in the sky. Sunlight still moves slowly across Pluto's heavens, because this world continues to rotate through a cycle lasting more than 6 Earth days. As the angle of illumination changes, the visible portion of Charon changes with it. At times, nearly the entire disk rests in pale gray light. At other times, only half of it is lit, and then it narrows into a thin curved sliver, still resting in the same region of the sky. On Earth, we are used to a moon that changes phase while also moving through many different positions overhead. On Pluto, the light seems to move across Charon, while Charon itself remains. Meanwhile, the ground beneath our feet continues through a very long day. The faint sunlight slowly touches mountain slopes, glides across icy cliffs, and then gradually withdraws from the broad plains. Darkness does not move quickly as it does on Earth. It stretches and shifts so slowly that an observer might hardly notice the difference over the course of a few minutes. Charon remains suspended above, not as a body traveling through the sky, but more like a fixed marker that helps define direction across an entire half of the world. In the places where Charon stands near the zenith, simply looking upward would tell us which side of Pluto always faces its companion. But that view is not the same everywhere. If we began a long journey across the surface and gradually moved away from the region facing Charon most directly, the gray world would slowly sink toward the horizon. The change would not happen because Charon was moving across the sky, but because the observer was walking across a curved surface, little by little turning away from a direct line of sight toward it. At first, Charon would still remain very high, and the difference might be almost impossible to notice. Over greater distances, it would begin to sit lower, standing closer to the horizon and nearer to the outlines of the far terrain. From a broad plateau, the full disk might still be clearly visible. In a deep valley, its lower edge might be hidden behind icy walls, leaving only the upper portion rising through the darkness. The farther one traveled, the closer Charon's curve would come to the horizon, until mountain ranges began to cut into the gray disk and hide it piece by piece. Near the boundary between the two hemispheres, Charon would remain only as a low round presence on the horizon. Its lighting would still change, but its position would remain almost the same. Only the ground beneath the observer would continue to carry the line of sight farther away from it. Eventually, the final curve of Charon would disappear behind Pluto's curvature, not because it had set, but because the observer had crossed into the portion of the surface from which it could no longer be seen. From that point onward, Charon would not return, no matter how much time passed. A long morning could begin. Light could slowly spread across the ice, and then fade again as night arrived, but the sky would still reveal nothing of Pluto's largest companion. Even seasons lasting for many Earth years would not change that. Charon would still be nearby, still pulling on Pluto through gravity, and still circling with it around the balance point between the two worlds. But Pluto's entire body would stand between Charon and anyone on the far hemisphere. So the same world can hold two completely different experiences of the sky. On one half of Pluto, Charon is an almost permanent presence, large enough to become a familiar part of the landscape. On the other half, it is never seen directly at all, even though its influence is still present in every rotation of the world beneath one's feet. One side can look up and see its companion still there, while the other can know of Charon only through motions that do not openly reveal themselves in the sky. The boundary between those two regions does not appear as a colored line or a wall across the ground. It is revealed only through Charon's height in the sky. In one place, the gray sphere stands high and clear. Farther away, it sits lower. Beyond that, it touches the horizon and disappears. If we returned along the same path, Charon would slowly emerge again, first as a thin curve, then as a wider portion of its surface, and at last high again in the sky. The scene might make it seem as though it were rising, but in truth Charon had never left its relative position. Only the observer had changed location. Here, the strangeness of Pluto's sky does not come from fast motion or violent change. It lies in a very slow order, where light shifts but direction remains fixed, where a world can stay present in the sky for billions of years from the perspective of one hemisphere and be entirely absent from the other. All of it begins with the fact that Pluto and Charon have settled into a shared rhythm precise enough for each to keep nearly the same face turned toward the other. And this relationship is not visible only from Pluto. From the surface of Charon, Pluto also hangs almost fixed in the sky, but because it is larger, more colorful, and wider in view, the sight is stranger still. To fully understand both sides of this shared dance, we need to leave Pluto's icy plains and look back from the gray world hanging quietly above. The space separating Pluto and Charon is less than 20,000 kilometers from the center of one body to the center of the other, a distance wide enough for each to remain a world of its own, yet remarkably small on the scale of the solar system. Our imagined journey from Pluto's icy plains to the surface of Charon, therefore, does not carry us somewhere entirely unfamiliar. When we turn and look back, Pluto is still there, larger, brighter, and almost fixed in the sky, just as Charon once appeared above the hemisphere facing it. From the surface of Charon, Pluto is no longer a tiny point of light in the distance. Its round disk occupies a broad region of the black sky, appearing far larger than the moon does from Earth. An observer would not need to search for it among the stars, because Pluto's presence would be far too obvious to confuse with anything else. Its curve stretches above Charon's gray highlands, carrying patterns of light and darkness, along with subtle colors that Charon itself largely lacks. While Charon's surface appears subdued, cold, and relatively colorless, Pluto overhead is far more varied. Some regions reflect light strongly, while others are darker and slightly reddish. Pluto's extremely thin atmosphere would not always be visible to the naked eye, but when sunlight passed through it at the right angle, it might form a soft, faint outline around the edge of the globe. From here, Pluto would not simply be an object moving through an orbit. It would become the largest and most colorful feature in the sky. Despite being so prominent, Pluto would neither rise nor set. Across the hemisphere of Charon that always faces it, the larger world would remain almost permanently in the same direction. The light across its surface could change, and its illuminated regions could narrow or expand as the angle of sunlight shifted. But Pluto's position relative to the landscape below would remain nearly unchanged. A cliff might always stand beneath it, a valley might forever face the same curve, and an observer standing still would not need to turn with the sky to keep Pluto in view. That stability would give direction on Charon a very different meaning from what it has on Earth. Here, looking toward Pluto would also mean looking toward the center of the connection that has shaped both worlds. If we traveled gradually away from the region facing Pluto most directly, its disk would sink toward the horizon, just as Charon had lowered in Pluto's sky. On the hemisphere turned away from it, Pluto would disappear completely, even though its gravitational influence would remain present in every rotation and throughout the long history of the icy crust beneath our feet. Across the part of Charon, where Pluto is always visible, the light would also change very slowly. At times, most of Pluto's disk would be illuminated, allowing its brighter and darker regions to appear more clearly. At other times, only a curved portion would be touched by the sun, while the rest remained in night. Because Charon and Pluto rotate together in the same rhythm, these changes would unfold gradually over many hours, without Pluto traveling from one horizon to the other. It would change phase while remaining exactly where it had always been. Even when most of the surface facing Charon was in darkness, Pluto would not necessarily vanish. The regions still touched by sunlight would form a thin curve, while the atmosphere might preserve a faint glow around the outer edge. Night on Charon would therefore not be a complete absence of the larger world. Sometimes, only a very small part of Pluto would remain bright, yet its outline would still be enough to remind an observer that the great sphere was directly overhead, resting in the same familiar direction. The exchange of light between the two worlds is gentler still. Pluto reflects part of the sun's light back into space, and a small amount of that light falls onto Charon. It is faint, far too weak to turn night into day, but it can spread a very thin glow across the landscape. The effect is similar to Earthshine illuminating the dark portion of the moon, the soft light that sometimes allows us to see the dim disk within the curve of a crescent moon. New Horizons observed traces of this light after passing through the Pluto system in 2015. When the spacecraft turned back to photograph Charon's night side, most of the surface was no longer receiving direct sunlight. Yet its dark regions remained faintly visible in light reflected from Pluto. In those images, a strip of Charon illuminated by the sun appeared clearly along the edge, while areas deep in night emerged only after the data had been carefully processed. Pluto, outside the frame, was quietly lighting its companion. Standing on Charon at a similar moment, that reflected glow might be just strong enough to soften the darkness. Mountain walls would not appear as clearly as they did in daylight, but the outlines of the terrain might still remain beneath a pale wash of light. Shadows would lose their sharpness, colors would nearly dissolve into shades of gray, and Pluto overhead would become a large but gentle source of illumination, unlike the sun and not quite like an ordinary moon. In such a landscape, the connection between the two bodies would no longer be something visible only in their orbits. It would enter the light falling across the surface itself. Charon receives sunlight and reflects part of it toward Pluto. Pluto also catches some of that light and sends it back across the darkness between them. Neither world is bright enough to illuminate the other with any brilliance, yet each still contributes a small amount of light to the other's night. Even so, Charon's sky would not remain completely unchanged. Pluto would hold its direction, but the sun would continue its slow passage overhead, altering the light across both worlds. Regions of Charon's landscape would still move from day into night, while Pluto above would change from nearly full to crescent and back again through its long cycle. The stillness here would not be a frozen picture, but a scene in which every change happens slowly enough to preserve a sense of balance. Looking from Charon toward Pluto, we would also begin to recognize something that is easy to overlook from far away. These two worlds do not simply sit beside one another in space. Each forms part of the other's sky, holding an irreplaceable position and reflecting light back across the darkness between them. One is grayer, the other more colorful. One is smaller, the other larger. Yet both have settled into a shared rotation that makes the presence of the other a permanent part of their geography. Pluto remains suspended overhead as darkness slowly spreads across Charon's plains. Its outline changes with the sunlight, while its position barely shifts. Across the frozen surface below, the faint reflected glow preserves the final contours of the landscape before the night grows deeper. But to truly feel the rhythm of this system, it is not enough to look only at the positions of the two worlds. We must wait for the light to complete an entire cycle, from an extraordinarily slow sunrise into a long-lasting darkness, to understand just how different a day on Pluto and Charon is from a day on Earth. Pluto remains suspended in nearly the same place in Charon's sky as darkness slowly spreads across the gray terrain. The sunlit portion of the disk overhead gradually narrows, while the extremely faint light reflected from Pluto preserves only a few blurred outlines on the ground. Time continues to pass within this landscape, but it does not leave behind changes as swift or obvious as those on Earth. A morning, an afternoon, or a night here lasts much longer, because both Pluto and Charon take about 6.4 Earth days to complete a single rotation. On our planet, light can travel from sunrise to sunset in only a matter of hours. The shadow of a roof moves across a courtyard, sunlight shifts along a wall, and the sky begins to darken before the day has had time to leave many traces behind. On Pluto, the same journey of light unfolds more slowly. The sun still rises, crosses the sky, and sets, but each stage is stretched out so greatly that an observer could spend hours watching the boundary between light and darkness move only a short distance across the ice. Morning would not arrive as a sudden transformation. First, a thin line of light would appear along the horizon, touching the highest mountain peaks before reaching the lower ground. Then the light would slowly flow down the slopes, move across the broad plains, and finally reach the floors of the valleys. The sun is extremely distant, so the landscape would not glow as brightly as it does during the day on Earth. Yet Pluto would not be lost in the dim, murky darkness we sometimes imagine. Around midday, the surface could be illuminated at a level similar to twilight on Earth after sunset, when the landscape is still clearly visible, but its colors have grown softer. Charon would remain in nearly the same position throughout this process. As the sun climbed higher, the angle of light falling across the gray world would change, causing the illuminated portion of its surface to expand or contract. Charon would therefore mark the passage of time not by crossing the sky, but through slowly changing phases that unfolded in one fixed direction. Over many hours, a thin curve could gradually widen into half a disk, then continue brightening until most of the hemisphere facing Pluto was clearly illuminated. Viewed from Charon, Pluto would pass through similar changes. The larger world would remain in the same direction while sunlight moved across its terrain. The two bodies always keep the same faces turned toward one another, but the sun is not held in a fixed position. Tidal locking, therefore, does not create one hemisphere of permanent daylight and another of permanent darkness. Every region on Pluto and Charon still passes through day and night in turn. Only the companion world in the sky remains without rising or setting like Earth's moon. This is an easy point to misunderstand. Hearing that Pluto always keeps the same face turned toward Charon might suggest that one side is frozen in endless night while the other receives light forever. But facing Charon is not the same as facing the Sunday. The pair continues traveling together around the sun, while each world rotates according to the shared rhythm of the system. Sunlight therefore continues to arrive from changing directions, carrying sunrise, midday, and darkness across the entire surface. Such a long day also gives shadows a different rhythm. Across a level plain, the shadow of an icy cliff might remain almost unchanged during a span of time long enough for an entire morning to pass on Earth. Only as the sun continued its slow motion would the shadow begin to shorten, change direction, and then stretch toward the opposite side. Surface regions would have more time to absorb warmth from the weak sunlight, followed by many hours in which to cool again during the night. Although temperatures would remain extremely low, these extended cycles of light and darkness could contribute to subtle changes in Pluto's ice and thin atmosphere. During certain special periods in the system's long orbit, Charon's path and the direction of the sun can become aligned closely enough for the two worlds to block each other's light. From some regions on Pluto, Charon could then pass in front of the sun and cast its shadow across the surface. Seen from the other side, Pluto could also block sunlight from reaching Charon. These events do not occur during every rotation because the orbital plane must be oriented properly toward the Sunday. When those conditions are met, the two worlds that normally remain almost fixed in each other's skies can carry their shadows across one another. These mutual events once helped humanity understand the sizes and surfaces of the entire system more clearly. As Pluto and Charon passed in front of each other from Earth's point of view, the total amount of light received changed. By measuring how much the brightness decreased and how long each event lasted, astronomers could estimate their diameters, reflectivity, and some of the distribution of bright and dark regions across their surfaces, long before a spacecraft ever flew past them. Light disappearing for a few hours became a way of reading the shapes of worlds, billions of kilometers away. Yet a day lasting 6.4 Earth days is still only the shortest rhythm in Pluto's calendar. The entire system takes about 248 Earth years to complete one orbit around the Sunday. A person born at the beginning of a Pluto year could never live long enough to see that year come to an end. During the time Pluto needs to finish a single orbit, many generations of humans would arrive and pass away on Earth. While at the edge of the solar system, the seasons would only slowly shift from one position to another. Day and year, therefore, belong to two very different scales of time here. A day lasts more than 6 of our own, yet it repeats thousands of times before Pluto completes a year. Sunrise continues to return across the icy plains. Charon continues changing phase in the same part of the sky, and the distance from the sun slowly changes along Pluto's long, slightly elongated orbit. Sunlight may grow somewhat stronger as the system moves closer to the sun, then weaken again as it travels farther away. But every change unfolds across a span too vast for a human being to experience in full within a single lifetime. Between these different scales of time, Pluto and Charon continue holding one another within the same familiar motion. Light passes across mountain slopes, darkness settles over the plains, and the illuminated phases slowly change, yet the two worlds remain turned toward each other. The scene may appear almost motionless, but it contains many layers of movement unfolding together. A rotation lasting more than 6 days, a shared orbit around their balance point, and a journey around the sun that takes nearly 2.5 centuries. When observed for long enough, the quietness of the Pluto Charon's system no longer resembles a motionless picture. It becomes more like a clock operating at an extraordinarily slow pace, with light as its most visible hand, while most of its movement remains hidden beneath the calm appearance of the sky. Charon never leaves its familiar position, yet the day continues to pass. Pluto remains suspended in Charon's sky, yet the light across its surface never stops changing. The stillness we perceive is only the result of several rotations fitting together so perfectly that they are difficult to separate. And before returning to the distant past to discover how this state came to be, perhaps we should pause for a moment within this balance and recognize that, on Pluto and Charon, what appears most motionless has been created by the most enduring motions of all. During a day lasting more than 6 Earth days, light continues its quiet passage across Pluto's icy plains, mountain slopes, and shadowed regions. Charon never leaves its familiar direction, yet the sunlit portion of its surface slowly changes. From the other side, Pluto also remains suspended in Charon's sky, larger and more colorful, while darkness gradually spreads across the gray terrain below. Seen over only a short period, the entire system can appear almost unchanged. The two worlds seem to have found a stable arrangement and simply remain there, as though every important motion had ended long ago. But this stillness is not the result of motion disappearing. On the contrary, it can exist only because many different motions continue at the same time and have become aligned with remarkable precision. Pluto still rotates on its axis. Charon does the same. Both travel around the balance point in the empty space between them, while the entire system continues along its long orbit around the Sun. No layer of this motion ever truly stops. Only when viewed from a fixed position on one of the two worlds do the different rotations blend together, making the other body appear almost motionless in the sky. It is a kind of stillness that exists only through relationship. If Pluto rotated even slightly faster, Charon would no longer remain in the same direction. If Charon completed its orbit more slowly or more quickly than Pluto rotated, it would begin to move across the sky. If either world changed its rhythm, the familiar balance would change with it. The scene before us is therefore not a property of Pluto alone or Charon alone, but the result of the way both worlds move together. We might imagine two people circling a point between them, each walking along a curved path while slowly turning to keep their gaze fixed on the other. If we watched only their faces, they might appear almost still. But if we looked down at their feet, the full motion would become clear. Every step, every change in direction, and the steady turning of the entire pattern. Pluto and Charon hold one another in a similar arrangement, except that their shared dance has not lasted a few minutes. It has continued across spans of time far longer than all of human history. Throughout our journey, Charon has gradually changed in the way we understand it. At first, it was only a slight bulge in an image of Pluto, a clue that could easily have been mistaken for an observational error. Then it emerged as a world nearly half Pluto's size, far too large to be treated as a faint satellite at the edge of the story. The balance point between the two bodies revealed that Pluto must also move in response to Charon's pull, while tidal forces explained why the rotations of both worlds eventually became synchronized. Each layer of understanding leads back to the same scene. Charon neither rises nor sets across the half of Pluto that faces it, while Pluto remains nearly fixed in Charon's sky as well. Yet understanding the present mechanism does not mean the story is complete. The balance we see today is only the final result of a very long history, while the earliest stages of that history remain hidden behind the regularity of the present. The two worlds almost certainly did not begin with the same orbits, distance, and rotation rates they have now. A young Pluto may have spun much faster. Charon may once have orbited closer, where the gravitational forces between them were stronger and the deformation of ice and rock was greater. Over time, energy was transformed, their rotations changed, and the distance between them gradually adjusted until the system entered its present state of double synchronization. Scientists can reconstruct this process through physical models, but they cannot return to observe the beginning directly. What remains are the present orbit, the composition of the two bodies, and the traces preserved across their surfaces. A fracture may tell of an interior that once expanded. A plain with relatively few impact craters may suggest more recent geological change. An unusually colored region may preserve material that once escaped from the neighboring world. Each clue is a small piece of history, but no single piece can tell the entire story on its own. The important question now is no longer only why Charon remains fixed in Pluto's sky. The deeper question is what brought the two worlds into this state. Did they form together from the same region of material? Or was one body captured after a rare encounter? Was Charon created by a collision, or did the real process unfold more gently, with two icy bodies coming together, briefly merging, and then separating again? These possibilities concern more than the origin of a moon. They determine how quickly Pluto may once have rotated, where Charon began its orbit, how much heat was produced inside both worlds, and why their surfaces now appear so different. To understand Charon's fractures, or Pluto's younger icy regions, we must first understand the circumstances in which the system was born. For now, the sky remains calm. Light continues to change across the two spheres, while their rotations stay aligned, as they have for countless generations. But behind that stability lies a past that may have been entirely different, faster, closer, and filled with more collisions. What now resembles a completed dance may have begun in a region of space that was anything but quiet. More than 4 billion years ago, the outer solar system was not the sparse darkness we imagine today. Countless bodies of ice and rock were still searching for stable orbits, colliding, merging, or being pushed onto new paths by the influence of the forming planets. It was within this unsettled environment that the material destined to become Pluto and Charon began to enter the same story. The stillness visible in the sky today is therefore only the final page, already open before us. To understand the whole story, we must travel back to a time when the two worlds had not yet found a shared rhythm, when the distance between them was not yet stable, and when the outer solar system was still slowly arranging itself. The quiet appearance of the region beyond Neptune today makes it easy to imagine that it has always been this cold, dark, and sparsely populated. Pluto continues along its long orbit. Charon remains almost fixed in the sky of the larger world, and other icy bodies are separated by distances so vast that each seems to exist in its own solitude. But if we could turn back time by more than 4 billion years, the scene would look very different. The young outer solar system was not a stable and orderly expanse. It was a vast region filled with countless bodies of ice and rock, growing, changing orbits, colliding, and searching for their places around the sunday. Today, this region is known as the Kuiper Belt, a broad, ring-shaped zone surrounding the Sun beyond the orbit of Neptune. It is not a solid ring of material, nor does it resemble the bright rings around Saturn. The bodies within it are separated by enormous distances, but when viewed across the full scale of the region, they form a vast population of icy worlds, smaller fragments, and many objects that have yet to be discovered. Pluto is the best-known member of this distant realm, but it is not the only world there. It belongs to a much larger family of bodies that still preserve material from the earliest days of the solar system. These distant icy objects are often described as remnants of the process that formed the solar system. The word remnants may make them sound like unimportant debris, but they are more like old pages preserved inside a frozen archive. Because they lie so far from the Sun, many of these objects were never heated as intensely as the planets of the inner solar system. Their ice, rock, and ancient compounds may still hold traces of an environment that existed more than 4 billion years ago, when the planets were still growing from dust grains, stones, and smaller bodies of material. Pluto also formed within that environment. The material that became Pluto once belonged to a broad disk of gas, dust, ice, and rock surrounding the young Sunday. Small particles collided and stuck together, gradually forming larger bodies. Through countless encounters, some continued growing, until their own gravity shaped them into rounded worlds, while many others were broken apart, pushed into new orbits, or never became large enough to form complete worlds. This process did not unfold in perfect calm. The giant planets may have shifted their orbits during the early history of the solar system, disturbing the material farther from the Sunday. As Neptune moved outward, its gravity may have pulled, pushed, and rearranged many icy bodies. Some became trapped in special orbital rhythms, some were scattered farther away, and others were placed on paths that gave them more opportunities to encounter one another. Pluto's present orbit, more tilted and elongated than those of the major planets, still carries traces of that period when the outer solar system was being reorganized. In an environment more crowded than the one we see today, collisions were not unusual, yet not every encounter ended in complete destruction. The outcome depended on the size, speed, angle of impact, and internal structure of each body. Two small icy objects might shatter into many fragments. One body might merge with a larger one. Under different conditions, two worlds might strongly affect each other while still preserving much of their original forms. These possibilities become especially important when we try to understand how Charon came to exist beside Pluto. There are three major explanations commonly considered when discussing the origin of a moon. Charon may have formed alongside Pluto from the same region of material, with the two bodies growing near each other from the beginning. It may once have been an independent world that passed close enough to be captured by Pluto's gravity. A third possibility is that Charon was born from the aftermath of a collision, when the young Pluto encountered another large body in the early Kuiper belt. At first, capture may sound like the simplest explanation. An object passes near Pluto, is pulled in by gravity, and becomes a moon. But in space, such an encounter is more difficult to settle than it might seem. If Charon merely approached Pluto and swept past, Pluto's gravity would accelerate it as it came closer, after which Charon could continue outward with most of its original energy. To remain, it would have to lose some of that energy. A third body, interaction with a disk of material, or an especially unusual encounter might be required to transform a brief passage into a lasting orbit. Without some way to remove energy, gravity alone usually bends a visitor's path rather than guaranteeing that it will stay. The shape of the present orbit also makes a simple capture story less convincing. Charon travels along a nearly circular orbit within a system that has reached a deeply synchronized state. Tidal forces can circularize an orbit and alter rotation over time, so the current arrangement cannot completely rule out capture on its own. But when the nearly circular orbit is considered together with Charon's unusually large size, scientists find that the system's origin probably required something more powerful and more intimate than a chance flyby. The possibility that Pluto and Charon grew beside each other cannot be dismissed either. The Kuiper belt contains many binary systems in which two bodies orbit a shared center. Some pairs may have formed from local clouds of material, or through gravitational encounters involving several objects when the region was more crowded. These ancient binaries show that two icy worlds existing together is not especially rare. Pluto and Charon, however, have proportions, compositions, and structures that suggest their story may be more complicated than a quiet process of growing side by side. For many years, the giant impact hypothesis therefore became one of the most widely studied explanations. In the classical picture, a large body may have struck the young Pluto. The collision did not completely destroy either object, but it placed enough material into orbit to form a disk of debris around Pluto. From this disk, pieces of ice and rock gradually gathered together, eventually forming Charon, while smaller amounts of material may have contributed to the creation of the remaining small moons. This story has similarities to the well-known hypothesis for the origin of Earth's moon, but the two systems should not be treated as copies of one another. Pluto is far smaller, much colder, and made from a mixture of ice and rock unlike the young Earth. Collision speeds in the Kuiper belt may also have been lower than those closer to the Sunday. The same phrase, giant impact, can therefore conceal very different physical processes. Most importantly, science has no recording of the moment Charon was born. Every hypothesis must be tested against what remains today: the masses of the two worlds, their compositions, their nearly circular orbit, the 4 smaller moons, and the geological traces preserved across their surfaces. Computer models allow imaginary bodies to meet at many different angles and speeds, then examine which outcomes might produce a system resembling Pluto and Charon as they exist now. For a long time, many simulations treated colliding bodies as large masses of fluid that could deform strongly and mix together. That approach was useful, but Pluto and the body that preceded Charon were probably cold mixtures of ice and rock, small enough for the strength of their materials to remain important. They may not have melted or blended together as easily as larger, warmer worlds. When the strength of ice and rock was included in newer simulations, another possibility began to emerge. The first encounter may not have been a violent blow that scattered material into a broad disk. Instead, it may have been a deep contact that held the two bodies together briefly before they separated and entered a shared orbit. In the still restless Kuiper belt, Pluto and Charon may not have begun in silence. Yet the encounter that created their relationship may also have been more subtle than an act of complete destruction. Somewhere between collision and merger, between capture and separation, the physics of two icy worlds may have opened a path that only recent models have begun to describe more clearly. In the crowded and unsettled outer solar system, the young Pluto probably did not travel alone through the darkness. Around it moved bodies of ice and rock along orbits that had not yet fully stabilized, sometimes passing one another at great distances, and sometimes coming close enough for gravity to alter the paths of both. During one such encounter, the object that would later become Charon may have approached Pluto not as a moon already prepared to enter orbit, but as an independent world carrying its own motion, mass, and history. The moment when the two bodies touched no longer exists for us to observe directly. No trace of light from that event is still traveling toward Earth, and no layer of ice has preserved the exact shape of those first moments. All science can do is begin with the pair of worlds we see today, then search for a physically plausible path that could lead from the distant past to their present orbit. For many years, collision models often treated large celestial bodies almost like enormous masses of fluid. That approach may work well for worlds that are extremely hot, or for impacts powerful enough to melt material and mix it deeply. When two such bodies meet in a simulation, they deform, flow into one another, and stretch into long streams of matter, much like two drops of liquid colliding in slow motion. From the material thrown outward, a new moon may eventually gather in orbit. But Pluto and Charon belong to a much colder region. They are far smaller than the large rocky planets, and much of their interiors consists of rock mixed with ice. During an encounter at a relatively low speed, that material would not necessarily behave like a liquid. It could fracture, compress, slide, and retain its strength long enough to change the outcome of the collision entirely. When the strength of ice and rock was included in newer simulations, the two bodies no longer merged so easily. Under the right conditions of speed, impact angle, and initial rotation, they could make deep contact while preserving most of their separate structures. Friction could dissipate some of the motion of the collision, preventing the two bodies from immediately bouncing apart, while the strength of the material kept them from merging into a single world. For a brief interval by the standards of solar system history, Pluto and the body that preceded Charon may have remained joined in an elongated shape, almost like two icy spheres touching across a shared region. They rotated together as a temporary body, not quite one world, yet no longer fully separate. Within the contact zone, ice and rock were placed under immense pressure. Some material may have been crushed or exchanged, while most of the two bodies retained the internal layering they had developed before the encounter. The image may bring to mind an enormous snowman lying sideways in space, but the resemblance in shape is not what matters. During this temporary state, Pluto's rotation and the gravitational pull between the two masses continued to act. Their connection did not last forever. After a relatively short time, Charon separated from Pluto's surface, but this time it no longer had enough energy to escape the system and continue into the Kuiper belt. It had been captured. This is why the scenario is known as kiss and capture. The name sounds far gentler than a collision between two worlds, but it does not mean the encounter was peaceful. Ice may have shattered, rock may have been compressed, heat was generated, and material may have been thrown away from both bodies. The difference is that the impact did not completely erase the identities of Pluto and Charon. Each preserved most of its own structure, and both continue to exist as separate worlds. This may help explain why Pluto and Charon have fairly similar densities today, while their surfaces and geological histories are not identical. If Charon had formed only from lighter material thrown off Pluto's outer layers, its composition might have been more noticeably different. In the newer model, the body that became Charon already possessed an internal structure before the collision. It was not created entirely from Pluto's debris, but entered the encounter as an ancient world nearly as old as Pluto itself, then remained behind in orbit. Some material could still have been released during the contact. Smaller fragments may have formed a thin disk around the pair, and later contributed to the creation of the 4 small moons orbiting beyond Charon. This part of the story, however, remains uncertain. The model still needs to be tested to determine whether enough material could have escaped, whether those fragments could survive within the system's complex gravitational environment, and whether they could truly have formed the small moons observed by New Horizons. It is also important to remember that a simulation is not a window opening directly into the past. A computer does not recreate what certainly happened. It allows scientists to test many possibilities and see which outcomes remain consistent with known physical laws. In each experiment, the impact speed, approach angle, internal structure, and initial rotation can be adjusted. Some encounters destroy the system, some cause the two bodies to merge. Others allow Charon to escape. Only within a certain range of conditions do the two masses touch, remain joined for a time, and then separate into a stable pair. For that reason, kiss and capture is not yet the final answer to the origin of Charon. It is a newly demonstrated path that can occur in physical models, an explanation that clarifies details older scenarios did not handle as well. Future observations, a better understanding of the world's interiors, and more refined simulations may strengthen or modify this picture. Although uncertainty remains, the scenario offers a beginning well suited to the unusual nature of the Pluto-Charon system. The two worlds may not have grown entirely beside one another, nor did they simply meet and continue on their separate paths. They came close enough to permanently alter each other's motion, but not so close that either one was erased from history. The contact was strong enough to keep Charon from leaving, yet gentle enough for both worlds to survive. When Charon pulled away from the contact region, its first orbit was probably neither as circular nor as wide as it is today. It may have remained much closer to Pluto, with each body filling a large portion of the other's sky and tidal forces far stronger than they are now. Pluto may also have been rotating rapidly, carrying energy left over from the encounter. The most violent part of the collision had ended, but the evolution of the system had only just begun. From that point on, no further major collision was needed to continue changing them. Gravity could complete the rest of the work at a far slower pace. With each cycle, Charon moved a little farther away. Each deformation removed a small amount of energy, while heat remained trapped beneath the layers of ice. Over time, the orbit gradually expanded, Pluto's rotation slowed, and the two worlds began their long journey toward the synchronized state we see today. When Charon separated from the contact region and began moving around Pluto, the two worlds were probably far closer together than they are today. The early orbit may not yet have been circular, their rotation rates were not yet synchronized, and the young Pluto may have been spinning rapidly under the influence of the encounter that had just changed its entire future. The most violent stage of their formation was over, but the Pluto-Charon system was still far from the quiet state we see today. At such close range, the gravitational forces between the two worlds were stronger than they are now. Charon raised larger distortions across Pluto, while Pluto continually caused Charon's ice and rock to bulge slightly and then relax again. This mechanism has already appeared in the story of tidal locking, but during the early stages, its effects did more than slow their rotations. It also quietly changed the distance between the two bodies. At the time, Pluto may have rotated faster than Charon completed one orbit. Because of this, the slight bulge raised by Charon's gravity did not remain perfectly aligned with Charon, but was carried a little ahead by Pluto's rotation. Charon continued pulling on that bulge, while the bulge pulled back on Charon in the direction of its motion. The effect during any single orbit was extremely small, but it transferred some of the motion stored in Pluto's rotation into Charon's orbit. Put more gently, Pluto slowed down so that Charon could move farther away. Energy and motion did not disappear from the system. Some of the energy was converted into heat within the ice and rock, while part of Pluto's original rotation was transferred into orbital motion. As Charon received more of that motion, its orbit gradually expanded. It did not rush outward all at once, nor did it leave Pluto along an easily visible spiral. Across countless cycles, the distance increased only a little at a time, far too slowly to notice within a human lifetime, yet enough to produce an enormous change when added together over geological time. In many models, Charon began only a few Pluto radii away from the larger world. Today, the distance between the centers of the two bodies is nearly 20,000 kilometers. That number cannot describe every step of the journey, but it shows how greatly the orbit has expanded since the early period. Charon no longer remains pressed close to Pluto as it may have been after the collision. A broad region of space now separates them, wide enough for both to appear as entirely distinct worlds while still remaining tightly bound by gravity. If the entire process could be compressed into a span of time short enough to watch, Charon would appear as a sphere slowly widening its path around Pluto. Pluto itself would also change, with each rotation lasting slightly longer than the one before. In reality, however, the transformation was neither quick nor obvious. For most of the system's history, it probably changed at an almost imperceptible pace, like the hand of a clock moving too slowly for the eye to see, yet completing its journey if we returned after enough time had passed. Charon was not separate from this process. Pluto gradually slowed its rotation, causing one hemisphere to remain increasingly fixed toward the larger world. Its early orbit, if it was once more elongated or eccentric, was also slowly rounded by tidal forces. Over time, irregular motions were reduced, much like ripples on water gradually settling after the source of disturbance has passed. Each time the two bodies were distorted by gravity, some mechanical energy was converted into heat. While Charon remained closer to Pluto, those deformations were stronger, so tidal heating may have played an important role, especially during the early stages of their evolution. The exact amount of heat depends on their internal structures, the shape of the original orbit, the stiffness of the ice, and how efficiently the material dissipated energy. These are all things that science can currently reconstruct only through models, so no single thermal history has been confirmed for both worlds. Even so, the possibility that heat once accumulated inside them reveals a picture very different from their frozen exteriors. Beneath the icy crust, some water may have melted or remained liquid for longer. Compounds dissolved in the water, such as ammonia, could have lowered its freezing point and helped a liquid layer survive in an extremely cold environment. Beneath surfaces that appeared motionless, Pluto and Charon may once have held underground layers of water influenced by leftover heat from formation, radioactive decay within their rocks, and repeated tidal deformation. Models do not fully agree on how long these water layers may have survived or how thick they might have been. Some studies suggest that the strongest tidal heating occurred mainly during the early period, when the orbit was not yet circular and the rotations were not synchronized. Other models focus on the possibility that internal heat, combined with compounds that lower the freezing point, allowed Pluto to preserve a deep ocean for much longer. On Charon, an ancient layer of water may have gradually cooled and frozen as its heat sources weakened. These remain possibilities under investigation, not scenes that have been directly observed. Yet freezing water does not simply become a quiet, stable, solid layer. Unlike most materials, water expands as it changes from liquid into ice. If a broad layer of water beneath Charon once froze, the increase in volume would have placed pressure on the crust above. A sphere cooling from within might therefore do more than contract. During certain stages, newly formed ice could stretch the crust and cause it to fracture. It is also possible that liquid material or soft ice once found paths upward through weakened regions, spread across the surface, and then froze. This would not resemble the glowing red lava flows seen on Earth. On an icy world, the material rising from below might consist of water, soft ice, and dissolved compounds, creating new plains beneath the light of the distant Sunday. But any traces of such activity belong to an ancient period, and there is currently no firm evidence that Charon remains active in this way today. As its interior changed, Charon continued moving farther outward while Pluto continued slowing down. The closer the system came to synchronization, the less the tidal bulges were displaced from the line connecting the two worlds, and the weaker the force changing the orbit became. The process did not end with a sudden stop. Instead, the differences grew smaller and smaller until Pluto's rotation, Charon's rotation, and their orbital period all met at about 6.4 Earth days. In this state, Pluto no longer pushes Charon outward as strongly as it did during the early period. The tidal bulges remain almost perfectly aligned, so the transfer of motion that once expanded the orbit has greatly diminished. The system has approached the endpoint of its tidal evolution, two worlds circling their shared barycenter while continually keeping the same hemispheres turned toward one another. The balance we see today, therefore, carries traces of a very long journey. The distance between Pluto and Charon is not simply an accidental gap. It is the result of motion transferred from rotation into orbit. Pluto's day, lasting more than 6 Earth days, was not an unchanging feature from the beginning. It is the rhythm left behind after the larger world gradually slowed under Charon's pull. If we could look backward through time from Pluto's surface, Charon would appear larger in the sky when it was closer, then slowly grow smaller as its orbit expanded. At the same time, Pluto's day would lengthen, sunlight would move more slowly across the landscape, and the ice beneath the surface would pass through a complex thermal history. Every change would be too slow for a person standing there to observe directly, but placed side by side across billions of years, they transformed the entire system into the form it has today. Charon is no longer drifting outward at the stronger pace of its early history. It has found a distance and speed suited to the shared rotation, while the tidal distortions that once generated greater amounts of heat have become much smaller. Most of that history can no longer be seen in motion directly, but it may still be preserved across the surface. If Charon's interior was once warmer, and if water once existed beneath the crust before gradually freezing, those changes must have left traces behind. And when New Horizons finally saw this gray world clearly for the first time, it found enormous fractures stretching across the surface, like the last surviving pages from an age when Charon was not yet as cold and quiet as it is today. The fractures mentioned at the end of our previous journey are not merely a few small cracks scattered across an aging surface. When New Horizons approached Charon in the summer of 2015, the gray world revealed an enormous geological wound, stretching across the part of its surface seen most clearly. Deep valleys, steep cliffs, and broad bands of terrain pulled apart from one another form a vast belt, as though the crust of the entire world had once been stretched from within and had never fully closed again. Before that encounter, Charon was often imagined as a cold, ancient, and rather monotonous sphere, where most of its history was told only through impact craters. A small world so far from the sun seemed unlikely to retain enough heat to keep changing, so its surface was expected to do little more than continue aging beneath occasional impacts. But the first close-range images broke apart that picture. Between cratered highlands lay long fault scarps, broad valleys, and smoother plains, revealing that Charon had not only been shaped by objects striking it from outside. Its own interior had once transformed the surface as well. The fracture belt near the equator may extend for more than 1,600 kilometers, nearly crossing the entire hemisphere, that New Horizons observed in detail, and perhaps continuing onto the far side, that was not photographed as clearly. Some valleys within this system are more than 6 kilometers deep. Beside them, the Grand Canyon on Earth is much shorter and shallower, even though Charon itself is only about 1,200 kilometers in diameter. On a world this small, such deep chasms are no longer local features. They belong to a transformation that affected the scale of the entire globe. If we could fly slowly above one of those valleys, the horizon would no longer appear as a smooth expanse of ice. On one side would lie an ancient highland, crowded with round craters layered across one another through time. On the other, the ground would fall into a deep shadowed region, where the distant sunlight touched only part of the cliff face. Shadows would remain across the valley floor for long periods because a day on Charon lasts more than 6 Earth days, causing the landscape to change very slowly beneath the light. There would be no strong wind moving through the canyon, no flowing water along the bottom, and no vegetation softening the broken walls. There would only be water ice as hard as rock, preserving the shape of an event that happened long ago. One widely considered explanation begins with a familiar property of water. When liquid water freezes, it expands. If Charon once held a layer of water deep beneath its crust, gradual cooling may have caused that ocean to freeze, increasing the volume within and pushing the outer shell outward. An icy sphere cannot expand without leaving traces. Its surface would be stretched, and when the crust could no longer deform gently, it would break apart into fractures, cliffs, and long valleys. This picture makes Charon seem like a world that grew slightly larger from within. The change may have represented only a small fraction of its total radius, but for a cold and rigid crust, that would have been enough to create an enormous system of fractures. No new impact from outside would have been necessary. The quiet transformation of water into ice beneath the surface could have torn open the terrain above. Yet the fractures alone do not prove with certainty that a deep ocean once existed in exactly the form described by the models. They show that Charon expanded, but the amount of water that may once have melted, the thickness of the crust, and the timing of the freezing process remain uncertain. Heat left over from formation, the slow decay of radioactive elements within the rock, and tidal heating during the early evolution of the system may all have helped warm the interior. Each source may have played a different role at different times, and the traces that remain today are not enough to separate them completely. South of the valley belt lies a relatively smooth plain, less rugged than the highlands to the north. This region appears to have been resurfaced by material rising from within. On Earth, the word eruption usually brings to mind glowing rock and streams of lava. On Charon, if a similar process once occurred, the rising material may have consisted of water, soft ice, and dissolved compounds that quickly froze in the cold environment. This kind of resurfacing by cold material is often called cryovolcanism, even though it lacks the visible heat and brightness of volcanoes on our planet. Some explanations suggest that water mixed with ammonia may have flowed onto the surface, because ammonia allows water to remain liquid at lower temperatures. That material may have spread across lower regions, partly covering older terrain before freezing into broad plains. But the path that carried it from the interior to the surface is still unclear. More recent models suggest that the icy crust may have been too thick for fractures caused by a freezing ocean to extend all the way from the surface down to the deep water layer. If so, the material that once resurfaced the plains may have come from a shallower region, from warmer ice capable of flowing slowly, or from a more complicated eruptive process than we currently imagine. That uncertainty does not make Charon any less compelling. Instead, it shows how a landscape can be clearly observed while the history that created it still contains many unresolved layers. Science can measure the length of the valleys, determine the height of the cliffs, and count the impact craters across different regions. From those details, researchers build stories consistent with physics, then continue testing which story explains the greatest number of clues without conflicting with the structure of the world as a whole. Impact craters also help place these changes within a relative timeline. A surface exposed to space for longer periods usually accumulates more craters, while a region resurfaced more recently erases some of its older scars. Charon's northern highlands carry more impact marks, while the southern plains appear smoother and seem to have been renewed at a later stage, though they are still extremely ancient by human standards. Most of the landscape seen by New Horizons has probably endured for billions of years, lying quietly beneath the increasingly faint sunlight at this great distance. There is no firm evidence that Charon is still cracking open, erupting, or reshaping its terrain in an observable way today. The great fractures appear to belong to an earlier period, when the interior remained warm enough and the system's tidal evolution had not yet fully settled. The gray world may now have cooled greatly, leaving the valleys behind like old seams across a crust that is no longer being stretched so strongly. Even so, ice on Charon has never been merely a motionless material. Under the right conditions, it can stretch, fracture, flow slowly, or take part in episodes of resurfacing. Cold does not erase geology. It simply causes geology to work with different materials and at a slower pace. Here, water may play the role that molten rock plays on Earth, while a freezing ocean can create deep valleys without a single river ever flowing through them. Charon therefore preserves its history in a remarkably direct way. The ancient highlands remain heavily marked by impacts. The valley belt still lies open across the surface, and the southern plains retain the smoother appearance of a region that was once renewed. Time has not erased these changes because there is almost no atmosphere. Liquid water does not flow across the ground, and erosion is extremely weak. Features created billions of years ago can remain there almost untouched, waiting for a small spacecraft from Earth to pass by and see them. Yet less than 20,000 kilometers from Charon, another world records time in an entirely different way. Pluto is also cold, also small, and illuminated by the same distant sunlight. But some regions of its surface are so young that they carry almost no impact craters at all. While Charon preserves its ancient fractures like a record closed long ago, the ice on Pluto may still move, circulate, and cover over the marks of the past. The two worlds rotate in the same rhythm and always keep the same faces turned toward one another, yet they do not grow old in the same way. The great fractures on Charon have remained almost perfectly preserved for billions of years, like ancient lines carved deeply into a crust that no longer changes very much. Less than 20,000 kilometers away, Pluto passed through those same ages, receiving the same faint sunlight and enduring impacts from the outer solar system. Yet when New Horizons brought both surfaces into clear view, they did not appear as differently sized versions of the same world. Charon preserves the past in cratered highlands and ancient fractures, while Pluto contains regions that seem to have been renewed far more recently. That difference begins with the kinds of ice covering each world. On Charon, water ice plays a role much like rock does on Earth. At extremely low temperatures, it is hard and durable, able to form mountains, cliffs, and a crust strong enough to preserve impact craters for immense spans of time. Pluto also has a foundation of water ice, but above it lie layers of more changeable material, mainly frozen nitrogen, methane, and carbon monoxide. In Pluto's cold environment, these substances form ice, but compared with water ice, they are softer, more volatile, and able to move across the surface in ways that Charon cannot easily sustain. When sunlight falls on a region for long enough, Some of the ice can turn directly into gas without first melting into liquid. This process is called sublimation, but on Pluto it is more than a chemical term. It is a way for material to leave the ground, enter the extremely thin atmosphere, and possibly travel to another region. When temperatures fall, the gas freezes onto the surface again, covering the landscape with a new layer. Over Pluto's long seasons, ice can disappear from one place and accumulate somewhere else, gradually burying or reshaping older features. Pluto's atmosphere is far thinner than Earth's, yet it is still enough to connect distant regions across the surface. Nitrogen makes up most of it, along with smaller amounts of methane and carbon monoxide. Sunlight, temperature, and Pluto's long orbit around the Sun continually change the amount of material moving between the atmosphere and the ground. Ice tends to collect in colder places, while in regions receiving more sunlight, some of it rises into the air again. Pluto therefore has more than weather in the familiar sense. It has a cycle in which the surface itself can become gas and later return as ice. The clearest sign of this flexibility lies within a vast plain called Sputnik Planitia. From a distance, this region appears brighter and flatter than much of the surrounding terrain. Seen more closely, its surface is divided into large cells with soft borders, as though the material were slowly reorganizing itself from below. Very few impact craters have been identified across most of the plain, suggesting that the surface was renewed recently enough in geological history that ancient scars never had time to accumulate as densely as they did across Charon's highlands. Beneath that smooth appearance, the nitrogen ice is not completely still. A very small amount of heat rising from Pluto's interior may warm the lower ice slightly, making it lighter and causing it to rise slowly. Near the surface, the material cools, spreads outward, and sinks again along the edges of the large cells. This motion resembles convection within an extremely slow-moving substance, continually bringing newer ice upward while drawing older material back below. Nothing in Sputnik Planitia moves quickly enough for a person to stand and watch it happen. An ice cell does not change shape over a few minutes or days, and the entire plain does not roll like the surface of water. Every movement unfolds across long spans of time, yet still faster than impact craters can accumulate. This allows the surface to remain young and relatively unmarked, even though Pluto itself formed near the beginning of the solar system. Along the edges of the plain, nitrogen ice also shows signs of having flowed across the landscape like glaciers. It moved around mountains of water ice, spread into lower regions, and left behind patterns that resemble glaciers on Earth, even though the material and temperatures are entirely different. Large blocks of water ice may rise through the softer nitrogen, much like rocks or islands caught within a slowly moving frozen sea. Here, water ice forms the rigid framework of the landscape, while more volatile ices cover it and change over time. The two kinds of material coexist, but they do not age at the same rate. Mountains of water ice may stand for billions of years, while the nitrogen around their bases flows, sublimates, and freezes again. A surface that appears to contain nothing but cold can therefore hold several different geological rhythms at once. Pluto does not require an intense source of heat to sustain all of this motion. Some heat may remain from the time the world formed, while the very slow decay of radioactive elements within its rocky interior continues to release energy. Its tidal history with Charon may have contributed more in the past when the two bodies were closer together and had not yet reached synchronization. Yet, there is no reason to attribute all of Pluto's geology to a single source. Weak but persistent sunlight, the circulation of volatile ices, internal heat, and the distinctive structure of each region may all contribute in different ways. The contrast with Charon is therefore not simply that one world is active while the other is completely motionless. Charon also changed dramatically in the past. It fractured, expanded, and may have experienced resurfacing by material from within. But most of that story lies deep in the past, and has been preserved on a surface with almost no atmosphere and little material capable of moving easily. Pluto, by contrast, has an additional layer of geology much closer to the present, where ice can travel through the atmosphere, flow around mountains, and cover older traces. Beneath the same distant sunlight, the two worlds have responded in very different ways. Charon preserves its fractures like an ancient record, while Pluto sometimes writes over its own surface with new layers of ice. One allows us to look deeply into the early past, while the other shows that cold does not necessarily bring all motion to an end. On Pluto, change does not require fire, flowing liquid water, or a thick atmosphere. With ices soft enough to move, a very small amount of heat, and enough time, the landscape can still shift. Ancient craters can disappear, plains can renew themselves, and material can leave the ground only to return somewhere else. But not every molecule that leaves Pluto comes back. A very small fraction may rise higher, escape the thin atmosphere, and continue drifting into the space between the two worlds. There, Charon's gravity may capture a little of the material that once belonged to Pluto. And over many long seasons, that tiny amount of matter may have left a mark large enough to be seen from far away. The dark red polar region across Charon's gray surface. Not every molecule that leaves Pluto's surface returns. Some of the gas in its thin atmosphere continues rising to greater heights, where the gravity of this small world is no longer strong enough to hold it forever. Most of the escaping material drifts away into the vastness of space, but occasionally, a tiny amount passes through Charon's gravitational reach and is drawn down toward its cold gray surface. There is no visible stream of gas connecting the two worlds, and no clouds stretching across the darkness between them. The exchange is scattered and sparse, with each methane molecule following its own path. Most disappear into space, while only a small fraction happen to pass close enough for Charon to capture. Over a day, a year, or even many centuries, the amount would be almost insignificant. But the Pluto-Charon system has existed for billions of years, and time can turn the smallest contributions into a mark broad enough to be seen from far away. When New Horizons returned the first clear color images of Charon, most of the surface appeared in subdued shades of gray, fitting a world rich in water ice and exposed to radiation for immense spans of time. The North Polar region, however, stood out in a deep red color, sharply different from the surrounding highlands and plains. On a world with so little color elsewhere, the polar region immediately became one of its most memorable features. The origin of that red coloring begins with extraordinarily long winters. The tilt and orbit of the system allow each of Charon's poles to remain in darkness for decades at a time. During those years without direct sunlight, temperatures fall low enough for methane arriving there to settle onto the ice instead of quickly escaping back into space. The methane does not cover the pole like a thick layer of snow. It accumulates only as a very thin coating, one that can easily disappear when sunlight returns. Yet while it remains on the surface, the methane molecules are exposed to ultraviolet light and energetic particles continually passing through space. Radiation breaks apart the simple molecular structures and recombines them in new ways, forming larger and heavier molecules. When winter ends, the pure methane gradually evaporates from the surface. The heavier products cannot escape as easily, so they remain behind on the ice. With continued exposure to radiation, this mixture slowly develops dark reddish-brown colors. Scientists use the general term tholins for materials created in this way. Tholin is not the name of a single compound, but of a broad group of chemical products formed when simple carbon-rich molecules are altered by light and radiation. The word organic can sometimes bring life immediately to mind, but in chemistry, it simply refers to compounds containing carbon. The tholins on Charon are not evidence of living organisms, nor do they suggest that life once appeared there. They show only that even in a cold, dry environment with almost no atmosphere, slow chemical reactions can still change the color of a surface. Each winter leaves behind only a tiny amount of material. Methane arrives, freezes, is altered by radiation, and then the more volatile portion escapes again when sunlight returns. The darker red products remain on the ground and become the foundation for the next cycle. After countless long seasons, the colored layer gradually grows thicker until a broad region around the North Pole becomes clearly distinct from the rest of Charon. A year on Pluto lasts nearly 248 Earth years, so each season continues for many decades. During an entire human lifetime, one of Charon's polar regions may still not complete its winter. The coloring process therefore unfolds not through rapid change, but according to the extremely slow rhythm of orbit, light, and chemistry. New Horizons clearly observed only the North Pole, which was illuminated during the flyby. The South Pole was then deep in darkness, but if this mechanism is correct, a similar process may occur there during its own winter. As the seasons exchange places, methane would have an opportunity to settle over whichever polar region had grown colder, then continue changing as sunlight gradually returned. Some details remain unresolved. Certain models also consider the possibility that Charon may once have released additional methane or other volatile substances from within. If that occurred, an internal source of material may have contributed to the polar coloring. Its role, however, has not been clearly established, while methane escaping from Pluto remains one of the leading explanations for the red region observed by the spacecraft. If this explanation reflects the true history, then the connection between Pluto and Charon is written not only in their orbit or in the deformations caused by tidal forces. Some material that once belonged to Pluto's atmosphere crossed the distance between the worlds, settled onto another surface, and slowly became color. Pluto lost molecules far too small to be seen, while Charon preserved their traces long enough for them to create an entire dark red polar region. There was no single moment when Charon suddenly changed color. The polar region is the result of many winters following one another, of weak sunlight, radiation, and methane molecules arriving from far away. Given enough time, an exchange almost too subtle to detect became a major feature of the surface. Pluto and Charon remain separated by thousands of kilometers of empty space, yet they have never been completely isolated from one another. Gravity holds them within the same rotational rhythm. Reflected light from each softens the darkness of the other, and material from Pluto may leave color behind on Charon. The two worlds do not need to touch in order to continue changing each other. Beyond this central pair, 4 smaller moons continue moving within the same gravitational system. They may have formed from fragments left over from the system's early history, but they never reached the same orderly stability as Charon. While the two central worlds always keep the same faces turned toward each other, the smaller outer moons rotate according to rhythms far more complicated and unpredictable. Beyond Charon's red polar region, where molecules from Pluto may have accumulated over countless long seasons, the system extends into 4 smaller orbits, each carrying a misshapen body whose motion is very different from that of the central pair. In order from nearest to farthest, their names are Styx, Nix, Kerberos, and Hydra. Compared with Pluto or Charon, all 4 are extremely small, so even in the best images returned by the spacecraft, only limited detail can be seen. Yet these tiny objects make the Pluto system far more complex than its quiet outer appearance might suggest. Charon is large enough for gravity to pull it into a nearly spherical shape, while the 4 outer moons remain irregular, resembling chunks of ice and rock that were never fully smoothed. Nix and Hydra are the larger members of the group, but even their average diameters are only a few dozen kilometers. Styx and Kerberos are smaller still. If placed within a broad landscape on Earth, each body would cover only a small part of the view, yet far away in space. They follow their own orbits and have continued moving around the central system for billions of years. Although they are usually called moons of Pluto, they do not orbit the center of Pluto in the simplest sense. Like Charon, the 4 small moons, the shared center of mass of the entire system, located in the empty space between Pluto and its largest companion. As they travel along their wider orbits, they are not responding to a single gravitational source that remains perfectly still. Before them are two large masses continually changing position around one another, causing the direction and strength of the gravitational pull to vary throughout each orbit. The orbits of these small moons are stable enough to survive over immense spans of time, but their rotations do not have the same regularity as Charon's. The large gray world slowed until it always kept the same face turned toward Pluto. The four outer moons have not reached that state. They rotate far more quickly than they orbit, so none of their hemispheres remains permanently directed toward the central pair. Nix and Hydra drew particular attention when Hubble observations showed their brightness changing in difficult-to-predict ways. Because they are elongated rather than evenly rounded, the amount of light they reflect toward Earth depends greatly on which side is facing us. When the observations were combined, their motion did not resemble a sphere rotating steadily around a fixed axis. Instead, they appeared more like irregular bodies, tumbling and changing orientation under the influence of a complicated gravitational field. In this case, chaos does not mean that the moons move without order or might suddenly leave their orbits. Their paths around Pluto and Charon can remain fairly regular even while the orientation of each body changes in a less predictable way. Standing on the surface of Nix, familiar ideas such as east, west, or the time when the sun would appear might not remain stable. One rotation would not necessarily repeat the one before it, because the axis of this small world could continue to wobble beneath the changing pulls of the central pair. Later observations from New Horizons showed that all four small moons rotate rapidly, with axes tilted sharply relative to the common orbital plane of the system. This makes them even more different from Charon, whose motion has settled into a deeply synchronized rhythm. Near the center is a pair of worlds that always keep the same faces turned toward one another. Farther out are small bodies spinning in directions that are difficult to picture, as though they still carry some of the unsettled motion left behind by the system's early history. Yet this complexity does not extend to every part of the system. While the rotations may be unpredictable, the orbital periods lie close to fairly orderly ratios with Charon's cycle. The time Styx, Nix, Kerberos, and Hydra take to complete their orbits is close to whole number multiples of the central pair's 6.4-day period. Some of these relationships are called resonances, meaning that the orbital cycles fall near ratios formed by simple whole numbers. There is no need to imagine them as gears locked rigidly together. The ratios are not perfectly exact, and the entire system is affected by many small gravitational pulls at once. Even so, these nearly regular rhythms may help prevent the moons from approaching one another too closely in dangerous arrangements. Although the bodies themselves rotate in complex ways, their orbits retain enough order for the entire group to continue existing around Pluto and Charon. This combination of order and uncertainty makes the four small bodies important traces of the past. They may have formed from material placed into orbit during the event that created Charon, though the exact details remain unresolved. If a disk of debris once surrounded the young pair, small pieces of ice and rock may have gradually collided, gathered together, and formed the moons we see today. Their elongated shapes, bright surfaces, and orbits lying near the same plane are all consistent with that possibility, but they are still not enough to reconstruct every stage of their formation. The small moons are not identical to one another. Some are brighter, while others are slightly darker. Some are larger but still elongated, while others are so small that the returned images reveal little more than a rough outline. Even so, they share one important quality: none has reached the rounded, synchronized balance of Charon. They resemble the final fragments scattered around the edge of a much larger story, in which the central pair gradually became stable, while the smaller pieces retained more complicated motions. Seen from far away, Pluto and Charon would establish the system's main rhythm, circling their shared balance point in a little more than 6 days. Beyond them, the four small moons would travel along wider paths, each carrying its own rotation rate and axial tilt. The scene would resemble neither a perfect machine nor a random collection of moving bodies. It would lie somewhere between those two images, a system held stable by gravity, yet complex enough that no rotation is exactly like the one before it. Most of what humanity knows about these tiny bodies comes from extremely faint points of light in Hubble images and a brief series of observations made as New Horizons passed through the system. No spacecraft has remained in orbit to follow them for years, and no instrument has landed on their surfaces to measure the ice directly beneath it. Our current understanding has been assembled from changes in brightness, blurred shapes in photographs, and the way each moon moves within the combined gravitational pull of Pluto and Charon. That encounter occupied only a tiny fraction of the system's history. After nearly a decade traveling across the solar system, the spacecraft approached Pluto, quickly observed the central pair and their small satellites, and then continued outward into the darkness beyond. During only a few hours surrounding its closest approach, points of light that had once possessed almost no visible shape became mountains, plains, fractures, and misshapen bodies of ice turning around one another. A single brief flyby had to gather enough information for humanity to begin reading a history more than 4 billion years long. The small moons around Pluto revealed only a few blurred outlines, a little reflected light, and rotations that were difficult to predict, because the spacecraft that saw them could not remain there. New Horizons traveled for nearly 10 years to reach this distant region, yet its closest encounter with Pluto and Charon lasted only a very short time. After a journey of billions of kilometers, the two worlds that had long remained as distant points of light had only a few hours to reveal their landscapes, colors, and the traces they had kept hidden for more than 4 billion years. When the spacecraft left Earth in January 2006, it carried with it a destination that still had almost no visible face. The best telescopes of the time showed Pluto only as a tiny disk of light, while Charon usually appeared beside it as a faint point. Humanity already knew their orbits, had measured their rotational periods, and was gradually beginning to understand the unusual connection between them. Yet no one had ever clearly seen a mountain range, a plain, or the edge of any deep canyon on either surface. Most of the journey passed in the silence of interplanetary space. New Horizons spent long stretches in hibernation to conserve power and reduce wear on its instruments, occasionally waking to check its systems or adjust its course. Pluto remained ahead, still too small and too distant to become a true world in the camera. Only as the distance began to narrow during the first months of 2015 did the 2 points of light separate more clearly, then slowly begin to acquire visible outlines. Each new series of images brought back a little more shape. On Pluto, bright and dark areas that had once blended together began to form broad regions. Charon appeared rounder and grayer, with a dark patch near its north pole. The first details were still blurred, but they were enough to create the feeling that the spacecraft was no longer approaching only a calculated set of coordinates. Ahead were real landscapes, with terrain of their own, growing larger in the frame with each passing day. New Horizons was never designed to stop. At Pluto's distance, slowing down enough to enter orbit would have required far more fuel than a small spacecraft could carry. It therefore had to make its observations while continuing to fly forward, like a traveler passing a window with only a brief moment to look into the room beyond. Every camera angle, every turn of the spacecraft, and every observation target had been planned in advance, because once the encounter began, there would not be enough time for new commands to travel from Earth and return. On the 14th of July 2015, the spacecraft entered the closest phase of its journey. During those hours, it was almost entirely silent toward Earth. Its antenna could not remain pointed toward home, while its cameras and instruments turned toward Pluto, Charon, and the smaller moons. New Horizons therefore worked quietly through a sequence of commands stored in advance, recording each image and measurement in its memory. On Earth, the people who had waited nearly a decade could do little more than trust that the spacecraft was continuing along its planned path. Pluto passed before the instruments as a world unlike the simple predictions that had come before. Tall mountains of water ice rose along the edges of bright plains. Reddish-brown regions lay beside areas that were nearly white, while nitrogen ice formed smooth surfaces with very few impact craters. The cold had not made everything motionless. It had simply created a different kind of geology, one in which ice could serve as rock, as glaciers, and sometimes as material still moving at an extraordinarily slow pace. Charon also emerged from the old image of an ancient and monotonous moon. Across its gray surface were heavily cratered highlands, an unusual red polar region, and an enormous belt of deep canyons stretching like a fracture through the world's crust. These landscapes did not tell the story of a body that had slept unchanged since its formation, but of one that had expanded, broken open, and may once have held water deep within. The encounter unfolded so quickly that the distance changed noticeably from 1 hour to the next. The highest resolution images were captured when the spacecraft was very close, and then that moment was immediately gone. New Horizons could not return for a second look under different lighting, nor could it slow down to watch a season change. It continued forward, while Pluto and Charon began to shrink behind it. Yet some of the final images carried a different kind of beauty. After passing the system, the spacecraft turned back toward the Sun, placing Pluto between itself and the distant light. From this reverse angle, the thin atmosphere appeared as layers of pale blue haze surrounding the curve of the world. Icy mountains stood near the horizon, while light swept across the plains, like an extended sunset in a place where the sun had become only a brilliant point far away. Charon's night side was not completely lost in darkness either. Some light reflected from Pluto reached across the gap, so faint that the surface details appeared only after the data had been carefully processed. It was a very small exchange of light between the two bodies, yet enough to preserve the outline of terrain in the night. The image seemed to gather together the entire connection explored throughout this journey. Two worlds keeping the same faces turned toward one another, changing each other's motion, exchanging material, and even casting a little light into the darkness of the other. Only after New Horizons had moved away did it begin transmitting everything it had seen. The stored collection of data was enormous, while the signal returning to Earth across billions of kilometers was extremely weak. The images and measurements therefore did not arrive all at once, but slowly returned over many months. The flyby had ended, yet Pluto and Charon continued to reveal themselves piece by piece on computer screens, as a new plane, another layer of haze, or a previously unseen region was gradually assembled. It took about 15 months for the final portions of the data to complete their journey back to Earth. By then, the spacecraft had continued deeper into the Kuiper Belt, while the old encounter was still expanding within human understanding. A few hours of observation became years of research, because every image contained more layers of questions than could be recognized at first glance. Even so, everything New Horizons returned was still only a brief glimpse. Some regions of Pluto and Charon were observed under clear illumination, while others remained in darkness or turned away from the most favorable viewing angle. The spacecraft could not stay to watch the atmosphere change through seasons lasting decades, nor could it look directly into the layers of water or rock hidden deep beneath the surfaces. Most of the internal history still had to be inferred from fractures, landforms, the composition of the ice, and the way the two worlds moved today. Even after humanity's closest encounter, Charon had not fully revealed its origin. The kiss and capture model still requires further testing. Its ancient subsurface ocean may have frozen completely, or some water may remain at greater depths. Regions that were not photographed clearly may hold landscapes different from the hemisphere seen by the spacecraft, while seasons lasting for decades continue to quietly reshape Pluto's atmosphere and surface ice. One day, another spacecraft may return and remain long enough to observe the entire surface under many angles of light, follow changes through time, and listen for the faintest signs from within. Until such a journey begins, however, our understanding still rests on the single passage of a small spacecraft, an encounter lasting only a few hours, yet one that completely transformed two worlds that had once existed only as points of light. New Horizons did not change Pluto or Charon. After it arrived and moved on, the two bodies continued circling the invisible point between them, keeping the same hemispheres turned toward each other and moving slowly along their long orbit around the Sunday. The change took place within human understanding. Charon was no longer a slight bulge of light beside Pluto, and Pluto was no longer a small, cold, simple sphere at the edge of the solar system. Since that encounter, their silence has carried mountains, plains, deep canyons, moving ice, and seasons that last for decades. Charon still appears almost motionless in Pluto's sky, but behind that stillness, an entire history has now emerged deep enough to lead us back to where our journey began. Charon is still there, holding nearly the same position in Pluto's sky. Sunlight moves slowly across the icy plains, illuminating the mountain walls before allowing them to sink back into darkness. Yet the gray world overhead neither rises from the horizon nor crosses the sky to set somewhere else. It simply changes phase in silence, sometimes fuller, sometimes thinner, while its distance and direction appear to remain unchanged. In that place, an observer could live through many long days and still see Charon resting in the same region of the sky. Darkness could spread across Pluto's surface, and the sun could complete its slow journey overhead. Yet the companion world would remain above like a permanent part of the landscape. Only if the observer traveled far toward the boundary between the two hemispheres would Charon gradually sink lower, touch the horizon, and disappear. Farther still, across the half of Pluto turned away from it, Charon would never be seen at all. This scene is not created by stillness. Pluto and Charon are both still rotating, both moving around the invisible balance point between them, and both traveling through the outer solar system along their long orbit around the Sunday. Charon appears motionless only because these separate motions gradually fell into alignment. One rotation, one orbit, and the rotation of the neighboring world eventually settled into the same period. That state was not present from the beginning. In the distant past, the two worlds may have been much closer together. Pluto's day may have been shorter, and the gravitational pull between them may have been stronger than it is today. Each time gravity deformed their ice and rock, some motion was exchanged, some energy became heat, and Charon slowly moved farther away. There was no single moment when the entire system suddenly became synchronized. The change accumulated across countless rotations, too small to witness within a human lifetime, yet great enough to reshape the entire relationship between the two bodies. Today, that history is no longer obvious in the rate at which the orbit changes, but it can still be felt in the distance between them. It is present in Pluto's day, which lasts more than 6 Earth days, in the way the same face of Charon always points toward Pluto, and in the way the larger world also keeps one hemisphere permanently turned toward its companion. The space between them has no surface and no color, yet it is the center of all their motion. Across Charon, enormous fractures still cut through the gray crust, preserving traces of a time when the interior had not yet cooled completely. Water may once have existed deep below, then gradually frozen, expanded, and pulled the crust apart. The smoother plains may mark places where cold material once rose from within and covered older terrain. Not every detail has been explained, but those fractures are enough to show that the world hanging quietly in Pluto's sky once experienced changes far deeper than its present appearance suggests. On Pluto, time has left a different kind of record. Some regions remain heavily marked by impact craters, while areas covered in softer ice continually bury or soften older traces. Nitrogen can move with extraordinary slowness, become gas under sunlight, and freeze again in colder places. The surface, therefore, does more than preserve the past. At times, it writes over it, creating bright plains, glaciers flowing around mountains, and regions far younger than the true age of the world itself. The two bodies are close together and rotate in the same rhythm, yet they have not become copies of one another. Charon preserves an older, more rigid surface, while Pluto carries more changeable layers of ice and a thin atmosphere that grows and retreats through its long seasons. One world holds on to ancient fractures, while the other continues covering parts of its past with new material. Synchronization in motion has not erased the differences that formed within each world. Even the empty space between them has carried material from one place to another. Methane molecules escaping Pluto may drift toward Charon, settle across its cold polar regions, and be transformed by sunlight and radiation into a dark red coating. Charon does not merely feel Pluto's gravitational pull. Its surface may also preserve a chemical trace from the neighboring world. The exchange is far too subtle to see as it happens, but given enough time, it has become a vast region of color. A spacecraft from Earth had only a few hours to observe these traces at close range. It swept past, returning images of mountains, plains, fractures, and thin layers of haze before continuing into the distance. But Pluto and Charon did not begin moving when humanity saw them, nor did they stop when the spacecraft departed. The encounter did only one small thing. It allowed us to recognize that the stillness out there was shaped by a history far richer than the points of light once seen through telescopes. There are still regions that have not been clearly observed. The precise origin of Charon may be revised as new models emerge. The deep layers of water beneath the ice may have frozen completely, or some may still remain in another form. Hemispheres that were not photographed in detail still preserve landscapes of their own, while seasons lasting for decades continue to pass without a spacecraft remaining nearby to watch them. That uncertainty does not make the scene feel incomplete. Charon still holds its place above Pluto's plains, even though we do not yet understand everything that brought it there. Its fractures, layers of ice, red polar region, and invisible balance point all reveal that the present is not an isolated moment, but the surviving result of a process that has continued through nearly the entire history of the solar system. The whole system continues around the Sun through a year lasting nearly 248 Earth years. The seasons change slowly, sunlight arrives more faintly, and the inner rotations continue with a precision shaped over immense spans of time. Across one half of Pluto, Charon remains visible. Across the other, it stays beyond the curve of the world, never entering the sky. The sun gradually sinks lower above a broad expanse of ice. Darkness passes over the mountain walls, flows into the lowlands, and spreads across the plains. Charon remains where it has always been, neither rising nor setting, while both worlds continue circling the empty point between them. Nothing has truly stopped moving. It is only that, given enough time, very different motions have found the same rhythm. And at the distant edge of the solar system, that stillness continues to be sustained by motion.